no assist. It's all average of all six quizzes. We will consider only average of all six quizzes. Okay, so today we're going to start. I think you guys are slightly lagging from other labs because in other lab I have completed unit number 1, logic and predicates. So in your case, it's not completed yet. I think so. So can anyone tell me what's the last topic I have covered in your case, in your batch? Because in other batches I have completed unit number 1 totally. If you guide me what's the last topic I have covered, then I can start from that. Have I completed that quantifier? Have I completed that argument, logical arguments, validity of arguments? Have I completed that argument? Have I completed that argument?
So I
Okay,
think
so we have completed existence. Yes, yes. Tell me, Neeraj.
simplification. I think
Uh, that quantifiers has been started. Universal quantifiers, existential quantifier. Then there are a few type of problems like this type of problems. Have I completed this type of problems? Only quantifiers. Okay, because I totally forgot what actually, because there are two lectures we are lagging because last week we didn't have lecture on Saturday and Monday. That's why. Existential quantifier finished. Okay. Okay, let's complete the unit number 1. Complete unit number 1 today, and later on, today our task should be complete the unit number 1. Okay, and in other classes, other labs, I have revised the unit number 4, 5, 6, and 1. Okay, I've solved the previous year question paper for them because they are two lecture ahead, two lab ahead. That means I will do the same for you after after 3 or 4 lectures or 3 or 4 labs. Okay, I will construct some extra lecture for you guys. Okay, don't worry. So let's start. Existential quantifier has been completed, so we'll move on towards the universal quantification and universal generalization. This concept is we were going to start. Okay, universal quantification and universal generalization. All right. So the very first thing you need to know. Okay, the attendance purpose. I will going to take the attendance at the end. Okay, don't worry. I will going to take the attendance maybe on the middle or maybe on the at the end. Okay. So universal quantification. Uh, so first of all, if you I think and you have to forget the stuff. What is universal quantifier? What is universal? I will solve that some examples and then I will explain that concept again. Okay, for you. Now, for the time being, you need to know what is universal quantification and what is universal generalization. Quantification means what? Quantification means it's a universal specification. Sometimes you can say universal specification. That is also a sounds well. Okay, that means uh, for all x p x is true. If the statement for all x p x is true, then uh, for all x p x is true means what? Universal quantifier. This is called universal quantifier. Universal quantifier. This is known as universal quantifier. And just for reminding purpose, what is universal quantifier? Universal quantifier is true. This is a statement. This is not a predicate. It's a specific statement. Universal quantifier is a specific statement. It is true only when it is true only when all all values of the predicates are going to be true. All values of the predicates are going to be true from that domain of discourse. So for reminder purpose, I'm going to say what is a predicates. Predicates is something like it's a group of statements. Okay, it's a where some variables is present, some variable x is present. Okay, and there are some domain present, like a domain of discourse known as from where I can borrow that particular variables. Okay, so universal quantifier means it's a specific statement. That means it is having some value, either true or false. So we can say that universal quantifier is true only when all the predicate value from the domain is true. Okay, and it is false only when it is false if I find at least one. Okay, if it is false, universal quantifier is false if I find at least one um, a false statement, at least one false statements among the all statements. If I find at least one false statement, then universal quantifier is false. Okay, so what is universal quantification or specification? That is known as, suppose a universal quantifier is true. Okay, suppose your universal quantifier is true means what? That means then PA is true for any arbitrary element A belongs to domain of discourse, because we know that if universal quantifier is true means it is true for that px, that all predicates value is going to be true in the domain of discourse. That means what we can write, we can specify this stuff that pa is true. Pa means a is any arbitrary value from the domain of discourse. So pa is true for any arbitrary element a belongs to the d. Okay, so this is called specification. I'm specifying this stuff. Okay, that we have some universal quantifier. I am specifying this stuff now. Now PA is true. We can say that PA is true. A is any value from the domain. Okay. We will use this stuff to prove some theorem or some to solve some problems. And stuff. Next, what is universal generalization? Universal generalization is just opposite of universal specification. Just an opposite of universal specification. That means what? If I have Px is true, what is given if Px is true when we replace x by an arbitrary value a from the domain of discourse. So if I have some Px which is true for any arbitrary value a from the domain of discourse d, okay, then what we can see, that we can say that for all x Px is true, then we can say that universal quantifier is also true. All right, then universal quantifier is also true in that particular case. That means we are generalizing the stuff. We are generalizing the stuff. That means what is given to us? Given to us that PA is true, where A is any arbitrary value from the domain. Okay, PA is true, which implies universal quantifier is true for all x Px is true. Okay, this stuff is known as universal generalization. Again, I will use this stuff, this both particular process in the proving some theorem or problem solving. The next stuff is that we are going to solve, this is a very important law, De Morgan's law for quantifiers. Okay, we can ask this in your exam also. What is De Morgan's law for quantifiers? Okay, so you have to prove this, and we already know what is De Morgan's law for using truth table or for any particular statement. Okay, so in a compound statement, we consider that De Morgan's law is if I remember, or if I remind back, that is between negation of there are two compound statements P and Q. So negation of P or Q. The negation of P or Q is equivalent to negation of P and negation of Q. This is known as the De Morgan's law for any statement. Right? Similarly, we can say negation of P and Q is equivalent to negation of P or negation of Q. Okay, so now we are going to prove De Morgan's law for quantifiers. That means there will be some predicates as well. So Px is, what is the statement? So Px is any given statement, any predicates. Px is any given predicates, and D is the domain of discourse, and capital D is the domain of discourse. Means the value of x, the value x, what we actually we can borrow the value of x from D, the domain of discourse. Okay. All right. Now, what is the statement? De Morgan's law. De Morgan's law states us that first is negation. Negation of for all x p's, that is negation of universal quantifiers. Okay, so negation of universal quantifier is equivalent to there exists negation of x p. That means existential quantifier of negation of px. These two are actually sounds similar. So negation of universal quantifier. Remember, negation of universal quantifier is actually equivalent to existential quantifier of negation of px. Okay. Similarly, the opposite. So negation of existential quantifier is actually equivalent to universal quantifier of negation of px. So this thing you have to prove. Use the logic. Okay. So we will start the proof. So first we will prove the first part. The first part is actually negation of universal quantifier is equivalent to existential quantifier of negation of px. So try to understand. I will explain each and every step. If you don't get any particular point, you can ask me on chat box at any point of time. So first, we will start proving this stuff. Okay? How to prove this? To prove this, we will assume the things that the first things we will prove that this implies this. First, we will prove that this implies this. Okay, and second we will prove that this implies this. So there were two parts to prove this stuff. Okay, the first part we will prove that this negation of universal quantifier implies existential quantifier of negation of px. Okay, the second thing we will prove that existential quantifier of negation of px implies negation of universal quantifier. That two things I will prove, and we will just use the concept, that is definition. Only we will use the definition of existential quantifier, universal quantifier, nothing else. So follow me and follow the steps. If you find that it's going to be difficult for you, please ask me on chat box. Okay. So I will explain you again on the stuff. So first of all, so we will start with let negation of universal quantifier of px is true. That means what? Negation of universal quantifier of px is true means what? Universal quantifier of px, xpx, universal quantifier of px is going to be false. Okay, this implies this. Is that okay? Because negation of universal quantifier of px is true. That means if I neglect this negation sign, so automatically if I replace the negation sign, automatically true becomes false, right? Simple. So moving forward, that means what? If universal quantifier false, now follow the definition of universal quantifier. If an universal quantifier is false, that means what? That means there exists at least one x. This is one, not on. That is at least one x belongs to the domain of discourse D, for which px is false. Clear? There must be exist one, at least one x. Okay, because when an universal quantifier is false, when we have at least one x from the domain of discourse such that px is false. This is from the definition of universal quantifier. And here we know universal quantifier is false. That means we can say there exists at least one x belongs to the domain of discourse such that px is false. That means what? There exists at least one x belongs to D. There exists at least one x belongs to D, for which, see, px is false means what? Px is false means negation of px is true. I didn't change anything. I just changed the last part of the line. Px is false means what? Implies negation of px Px is false means negation of Px is true. See, what is our target? Our target to prove the uh, uh, existential quantifier of negation of Px. That's why I want to bring this negation of Px back. That is our target. That's why we will approach towards the target, nothing else. We will not making any arbitrary move. Our move is only specifying towards the proof. Okay, we have some specified move, and that is towards the proof only. Okay? Now, what is the meaning of this? It means that there exists negation of XPS is true. This is the definition. We can say that there exists at least one X belongs to D for which negation of Px is true. That means what? There exists, by notation we can write there exists negation of XPS is true. That's all. I started from here. I started from here. I finished here. I started from here. I finished here. That means I proved that. That means what I proved? The first part. I have proved the first sub part. I have proved the first part, that is this implies this. I have proved that that implies this. Okay. Now we have to prove the opposite, reverse part. We will prove the reverse part. So what is the reverse part? I will start the reverse part over here. Now reverse part, we will assume that there exists negation of xpx is true. That means existential quantifier of negation of px is true. That is what I assume. If the right side is true, I am assuming the right hand part is true. Okay. Now what we have to prove? We have to prove the left hand part is true also from here. Okay, by using the definition only. Okay. So simple things. What is the meaning of this? There exists negation of xpx is true. Now I will write it in theoretical manner. I will write it in theoretical manner. That means there exists x. Try to understand. There exists x for which negation of px is true. Simple in language. Simple in language. There exists. That means existential quantifier of negation of px is true. Simple in language. What is the meaning of this? There exists x. X belongs to D. You can also write instead of x. You can also write x belongs to D. There exists x belongs to D for which negation of px is true. All right. Now we don't want that negation of px because we want to prove that negation of for all x px, right? Negation sign is outside. So now the next step is I will replace the last part only. I will replace the last part. The negation of px is true. Everything is else is same. So negation of px is true means what? Px is false. Negation of px is true means what? Px is false. So there exists x belongs to D. There exists x belongs to D. You can same write the same. There exists x belongs to D for which px is false. There exists x belongs to D for which px is false. Now think about this. There exists x belongs to D for which px is false. Now look at this line. Look at this particular sentence. There exists x belongs to D. One x belongs to D for which px is false. And what is this sentence? There exists x belongs to D for which px is false. That means we are nearer to proof. That means what does it mean? It means that for all x px, it means that for all x px, that is universal quantifier. Look at this line and this line, both the same. Universal quantifier of px is false. Because why? Because there exists x belongs to D for which px is false. We have some x in the domain of discourse for which we find that px is false. That means what? Universal quantifier is false. Simple. Universal quantifier false means negation of universal quantifier is true. As simple as that. Negation of universal quantifier is true. Now look at this. We started from here. We ended up at here. That means we prove that reverse part is also false. That means we prove that first part of Democles law holds true. Okay, this is the this is the total logic, and everything is crystal clear. Nothing else is hidden here. Everything is crystal clear. Now write down on chat box, is it okay to you or not? Write down clear on chat box if it's clear. Otherwise, ask me your doubt. Write down clear on chat box such that I have the clarity whether it is clear or not. Okay, write down clear on chat box. All of you, quick. If you have doubt, you can also ask me. But please write down clear on chat box. All of you, only 5 or 6% is writing. See, if you're not active enough, then I will mark you absent. Okay, because I will mark you present depending on your appearance in the chat box. I don't want your physical appearance. Okay, your mental presence is important. All right. Still, many students didn't reply it. It's okay. Don't worry. Attendance is still my hand. No problem. Okay. So moving forward to the next part of De Morgan's law of quantifier. That means we proved that this first part has been proved. Okay. Now moving towards the next part of De Morgan's law of quantifier. Okay. Now what you have to prove? There exists a negation of existential quantifier of Px actual equivalent to universal quantifier of negation of Px, that we have to prove. Similar manner, there will be two parts. One is the forward part, and one is going to be the reverse part. So try to prove it. I will give you 5 minutes of time. Once you have done with that, say done on chat box. Otherwise, I will guide you on that. Okay. Try to prove this stuff. Okay. I'll give you 5 minutes of that. Start from LHS, go to RHS, and the second reverse part, start from RHS, go to LHS. Simple, straightforward manner. Follow the definition. Just try to follow the definition. Go for it. Go for it and write down done on chat box once you have completed the stuff. Write down done on chat box. All right, I think no one has tried yet. So anyone's tried? Okay, Janet was completed. Okay, let's check. The first stuff we need to show that the front side. Okay, front side is actually, that means negation of existential quantifier. Negation of existential quantifier is true. We assume that, and we will prove that from here that universal quantifier of negation of px is going to be true. So what is the meaning of, what is the theoretical meaning of this? That negation of existential quantifier is true means existential quantifier of px is false. Existential quantifier of px is false means what? False. So existential quantifier of px is false means what? Means every value of px is going to be false. As you know the definition, for all, yes, every value for all x belongs to d. What we can write? For all x belongs to, for every x belongs to d, px is false. So we can write theoretically, for every x belongs to d, we can write belongs to d also. For every x belongs to d, or normal for every x is also okay. Okay, so what we will write? For every x belongs to d, for every x belongs to d, or for every x, px is going to be false. Now for every x, px is going to be false means what? Means for every x, negation of px is true. Am I clear? Because we are interested in negation of px. All right, so for every x, px is false means for every x, negation of px is true. Now for every x, negation of px is true. That is what, by notation we can write universal quantifier of negation of px is true. Universal quantifier of negation of px is true. That's all. That means what we have to prove? This one. For all negation of x, px is true. That means we started from negation of existential quantifier is true, and we ended up at universal quantifier of negation of px is true. That means we proved the first part. That means front part we have proved. This first part we have proved. Okay, now we will start the reverse part. The reverse part, in the case of reverse part, we will start from, for all negation of px is true. That means universal quantifier of negation of px is true. That means what? That means by default we will write for all x, px is false. Okay, because see, an universal quantifier of negation of px is true means what? Universal quantifier of px is false. That is what it means. Universal quantifier of negation of px is true means what? Universal quantifier of px is false. Okay, now moving forward, that means what? Universal quantifier of px is false means by definition it is false means there exists at least one x. There exists at least one x belongs to d. You can say belongs to d also. There exists at least one x belongs to d such that px is false. Now there exists, we come to the, once I'm coming to that particular language, there exists. There exists means existential quantifier. There exists means we are coming in the point of existential quantifier. So there exists x such that px is false means what? There exists x such that negation of px is true. There exists x such that negation of px is true. Am I clear? There exists x such that negation of px is true. Just I'm changing the last part, which means negation of there exists xpx is true, which means negation of existential quantifier of px is true. Okay, because there exists x for which negation of px is true. That's why we can say that negation of existential quantifier is true. That means we prove the reverse part as well. So simple, if you follow the definition and just follow the one line by line, you can definitely reach towards the first part and also the reverse part of the proof. So that's all about the proof of the second part of De Morgan's law of quantifiers. We can ask you on that in exam also. We can prove that a state and prove De Morgan's law for quantifier also. Okay, for 8 marks. So be careful about that also. All right, moving forward to the problems. So let's start solving some problems now. I'm stopping the recording now.